The community that water built. Water has always played an important role in the economy of the Sault Ste. Marie area, and so when one of history's greatest inventions, electricity, burst forth in the world in the 1800s, it didn't take long for people to realize the potential of hydroelectric generation at the great spillway from Lake Superior, the Falls of St. Mary.
The first serious effort to develop this water power started in about 1885. And the plan at that time was to dig a canal about 3 miles long from the head of the rapids, running almost east, a little bit south of east, and terminating at Little Rapids, which is roughly where the golf course is today. There was going to be 100 acres of mill sites down at the lower end of the canal then, and even access for boats to bring in raw materials and take away the finished product. In 1889, the money ran out, and things remained that way pretty much until the middle 1890s.
In 1894, Francis Clerg, representing a group of New England investors, came to the Sault in search of a good spot to develop hydroelectric generation and industrial development. Within 3 years, he developed an industrial empire in Sault, Ontario, and then sought to purchase and complete the canal and powerhouse construction in Sault, Michigan. Clerg established the Lake Superior Power Company and hired a renowned engineer, Hans von Schoen, to lead the construction. The original designs for the powerhouse envisioned a variety of industries using the second and third floors. When Union Carbide emerged as the sole tenant, the construction was changed. The carbide required continuously operating extreme heat electric furnaces to burn a mixture of limestone and coke to produce a stone-like substance called calcium carbide. When this substance was put in water, it gave off a vaporous gas called acetylene that burned with an intense hot flame. The main use for acetylene has been in welding and shaping steel, and as a chemical in making of plastic products. The carbide wanted to utilize 120 furnaces on the second floor, so the design of the powerhouse needed to have a high ceiling and a vented roof on the east end to release the heat. Therefore, the third floor was eliminated and vents were added. Von Schoen designed the plant to produce 40,000 horsepower. Union Carbide would need 20,000, leaving an excess of 20,000 for other industries such as pulpwood manufacturers. Each generator could only produce 500 horsepower, so to produce the full 40,000 horsepower, 80 penstocks would need to be built, housing 80 generators, powered by 80 tandem turbines. To make all the turbines spin efficiently required a consistent amount of water at a specific level and speed. The mathematical calculations of this led to the construction of a canal 2¼ miles long, 200 feet wide, and 24 feet deep, controlled by 4 steel headgates. This provided an effective head of 18.4 average feet, the difference between the level of the powerhouse forebay and the St. Mary's River.
The entire project then to build the powerhouse and excavate the canal and the headgates and so forth took 4 years to complete. So it really was a festive mood in October of 1902 when the grand opening celebration took place. 5,000 townspeople were invited to have dinner up there on that second floor. So enormous tables were laid out. Waiters were brought in from Chicago for that.
Union Carbide continued to grow and purchased the powerhouse in 1913, naming their power company Michigan Northern. But it wouldn't be until 1920 before the hydro facility would stabilize and begin running at maximum capacity because of structural repairs and legal and financial entanglements. Eventually employing more than 500 people, the carbide and their new power company became the dominant industry in the Sault for decades.
And these boats came in about 2 a month. And we loaded 100-pound drums, 3 60-pound drums, and we loaded, at the last, we loaded 1,000-pound drums. And then they went from there to railroad, and they shipped out of the shipping room from there up to the transfer on the Sault Line Railroad. During World War II, they start making calcium metal for the government. And I was put on as a foreman, and we had 5 furnaces up over the powerhouse second floor.
The products made at the carbide played an essential role in the manufacturing of hardened steel for the war. After the war, new facilities and processes were implemented, and 2 large covered furnaces replaced all the old ones. But the plant's days were numbered due to space constraints and cost considerations, and in 1963 the carbide moved out, tearing down all their structures next to the powerhouse. And in May of 1963, Edison Sioux Electric Company purchased the facility.
Okay, in 1963, Edison was operating a coal-fired plant, and the need for power in the UP was increasing to where they had to have extra generation. At that time, it was a 25-cycle DC plant with all power being used by Union Carbide. They rewound all the generators to 60-cycle and got the plant up to where it was strictly used for generation purposes.
Generating hydroelectricity from lake water required that Edison set up an operations and systems control department. The systems department responded to water flow directives from the International Joint Commission by operating the plant in a maximum peak mode only during times of high usage, then backing the water usage off during nights and weekends. 31 people were employed in the plant because every gate setting had to be made by hand 2 or more times a day. As of 1991, new equipment and gate positioners were installed, all operated by a computer. Now, only 10 people are needed for a 24-hour operation. 5 phases were needed to successfully convert the plant to computer control.
The 5th and final phase was the automation of all the units using what we call an MED, Most Economic Dispatch Computer. That computer resides in this control center. We're allocated a certain amount of water. We open our head gates that are at the intake of this canal, roughly 2¼ miles away. We have monitors in the forebay that measure the water level in our forebay. We have monitors on the tailray side, measures the lower river. We also had an indexing study that was performed by the University of Minnesota back in the late 80s. We monitored the flows in each penstock, and there are 72 of them, for different gate opening settings and also different forebay water levels. All that information was assimilated into an algorithm that is essentially software within the computer that operates this plant now. We have a turn-of-the-century technology, which is the old granite board that's in front of me here, and that's the way the operators used to operate this plant. Adjacent on the same level are the new panels. Each generator has a cabinet which has 3 different components to it. One is the PLC, Programmable Logic Controller. Second would be the high voltage compartment, which has the high voltage fuses that connected to the generator. And the third would be the excitation panel, which provides DC excitation to excite the fields of the generator so we can produce electricity. And right here we have a monitor which depicts our entire transmission system on one screen, and the different colors indicate different voltage classes. And where we currently reside on this screen is up here in this one corner, Sioux Hydro Plant, and down in this corner would be the Straits of Mackinac area, and over in this corner would be Manistee, roughly 120 miles away. All these little red squares can be operated, open and closed through this keyboard, and the dispatcher controller can monitor all the flows on the various transmission lines.
The powerhouse is a symbol of the best of the old-style craftsmanship with the latest and efficient technology. The water that made our community will continue to make it better for generations to come.